Okay, Assalamualaikum. We continue with our covalent bonding. Okay, so how is covalent bonding formed? Electrons are shared here to form a bond. Instead of giving up and receiving the electrons, as we found in the ionic bonding, the covalent bonding is formed by sharing the electrons, by sharing the electrons. Okay, most frequently occurs between atoms with similar electronegativity. So it is between the electronegativity elements, okay, such as in the group 16 and 17. Okay, so it is no more between the group 1 and group 2 is group 15 and 16 or 17, but the covalent bonding is between the similar group 15, 16 and 17. Okay, molecules with non-metals, so it cannot be found in the metals element. Molecule with metals and non-metals, okay, aluminum phosphide, non-metal elemental molecules such as the hydrogen, chlorine, fluorine, and etc. Okay, elemental solid, diamond, carbon, silicon, germanium, and so on. Okay, compound solid about column 14. Let's see the group 14, column 14. 7654, okay, around here. Okay, yes, gallium arsenide, indium antimonide, and so on lah. Okay, so this is the examples of how it shares its electrons to form the covalent bonding. Okay, let's say we have the methane here, CH4 methane. If the name in the real life we call it the natural gas. Okay, CH4. C has 4 valence. Okay, how do you know that? You have to refer back to the periodic tables, how many electrons carbon has. So it has 14 electrons. So when you have 2 and 10, okay, let's see, I try to draw for you. Okay, so this is the carbon. Okay, so at the first shell we have 2, and the second shell we have 10. Carbon has 14. And so we have to put 4 more in the most outer shell. Okay, sorry, you cannot write in pair for the most outer shell, the more valence shell. You have to put it like this. Okay, so the carbon here have 4, 1, 1, 1, 1 in the separate combination of electrons. Okay, so how to get the stable form? You have to get 1 electron, 1 electron, 1 electron, and 1 electron. So it needs more 4 electrons to get the stable forms, to form to get the 8 electrons at its shell, on the most outer shell. So how do we get the stable form? We have to share. Okay, let's say it combined with the hydrogen. So we know that hydrogen only has one electron. So write that. Put another color here. Okay, like that. So okay, so now we have two here. So hydrogen have two electrons. So hydrogen here is stable. Okay, but carbon still is not stable. So you have to put another 3 hydrogen. Hydrogen has only 1 electron. Okay, right. So now we have the stable of electron configurations in all elements. Okay, for the carbon, it has 18. For the hydrogen, it has 2. How it gets the stable form? It gets by sharing the electrons between them. So this bonding, we call it covalent bond. Okay, so now how to write the formula of a chemistry formula here. So we have one atom C, we have 4 hydrogen, so we put H4. So that's what we call CH4. Okay, methane or natural gas. Okay, so the properties of the covalent bonding. There can be found in the gas form or liquid or solid form. Okay, and yes, it has poor electrical conductors in all phase because the electrons are not moving here. It is that I did not say that electron is not moving. I say that electron is not transferring from the elements to the another elements. Of course, electron is moving on its shell, but it is not transferring. It's not transferred between the elements here. So it doesn't have the electricity conductivity properties. Okay. It can be hot, it can be strong, it can has a high melting temperature, it can lower boiling point or high boiling point. So it is variable. Okay, maybe it has hot or strong and so on lah. So it depends on the combination of element itself. Okay, so example of covalent bonding. Okay, hydrogen here between carbon, yes, we have CH4, C2H6, and so on. And we also have the H between the O. Yes, we have H2O, water. And the fluorine itself, between its element itself, it can be found in the fluorine. Yes, gas fluorine and also gas chlorine and so on. Okay, so molecule with non-metals, a molecule with metals and non-metals, such as titanium oxide and so on. Okay, elemental solids, compound solid, about column 14 here. Okay, the carbon itself can be found by its own elements. Okay, let's say as the diamond. Okay, so the diamond is one of the hardest natural material found on Earth. Okay, so the covalent bonding itself in the carbon that form the diamond is the hardest natural material in the world. Okay, so exercise, draw the following covalent bonding: single bond, double bond, and triple bonds. Okay, so I show you the oxygen. Yes, how do you know the oxygen has how many electrons? Yes, so once again you can refer back to the periodic table, but we remember this is the common, it has 16. So the outer shell here, okay, has 1, 2, 4, 6, 8, 10. So it has 1, 2, 3, 4, 5, 6. Okay, so let's say okay, I put it here. Okay, 16. So we have another oxygens. Oh, sorry. Okay, another oxygens. Okay, I just put it as 16. Hiya, 16. Okay, so we have the 6 electron at in the most outer shell. 2, 4, 6. 4, 6. Okay, so here we have to yes, is it correct? Aduh. Oxygen 16 is the mass number. Ayah, 8 je electron number dah. Saya lupa dah pula. Sorry. Ayah. Oh. I confuse the mass number with the proton number. Okay. This one. And the other one for the other atom of oxygen. Okay, so the oxygen itself has how many protons number? 8. Okay, so it means that the proton equal to the electron number, so the proton number electron number is also 8. Okay, so 1, 2, and the other Valence number is 6. One here, one here. One, two, three, 4, 5, 6. Okay, so how do you get the 6 here to get to form the 8 electron valence? You have to share double bond. Okay. How do you get the double bond? Okay, let's continue after this. I have to go to the bathroom first. Toilets. Okay, now let's continue. Okay, how it means for the double bonds. Okay, so we have to put 2 here from the left side oxygens and 2 here from the right hand side oxygen here. So you will get the double bonds. Okay, so from the original one here, I put 1 here, 2, 6. Okay, right, so it has the total 6 here. And this one, the right hand side, we also have to put 2 here, so you will get 2, 6, 4, 6. So you should have to put here. So this is what we call the covalent bonding, double bond. So we total up, you have 8 electrons at the most outer shell for both oxygen. So that's why it can be found in the form of O2, the gas of oxygens. Okay, so similarly to the nitrogens, you will get the 3 here and 3 here. So that's why we call the triple bonds. This one pair is one single bond, and this one is the double bond. Okay, so that's it for the covalent bonding. To make sure you have learned or understand about the covalent and ionic bonding, so make sure you do your tutorial questions. Okay, and now finally the third one is the metallic bonding. Okay, how's the metallic bonding form? Occur when some electrons in the valence shell separate from the atom and exist in cloud surrounding all the positively charged atom. Okay, the valence electron form a sea of electrons, found for group 1 and group 2 elements, found for all elemental metal and its alloy. So it only found in the elemental metals and alloy. What alloy means is alloy is the combination of 2 or more element of metal elements. Okay, so the metallic bonding, let's say this is the metal ions, the free electrons from the outer shell of metal atom, and then you will get the what we call sea of electrons here. So many electrons, and then it will attracted between the ion and cation and anion, between the positive charge metallic ion and negative electron clouds here. Okay, so let's say this is the zinc. Okay, cation of zinc, ion of zinc. So the electrons, sea of electrons here will attract between the anion and the positive charge in the zinc, between the negative charge in the electron itself. So that's what we call the metallic bonding. So the properties of metallic bonding, as we know, yes, metal is the good electrical conductivity. Yes, metal also has a high heat conductivity, but it is ductile and is opaque. Okay, yes, this is transparent to all visible. Okay, so I can skip this slide. Okay, so now just a general questions. Explain why are metals ductile, can conduct electricity, and has high melting point. Okay, can you explain that? Okay, I'm waiting for the answer. You can just put it in the WhatsApp group if you know. You try to think it by your own self. If you have the problem, you can try to Google first, find the answer. But as we can see from here, we know that why it is ductile. Yes, because the bonding between the element itself is not strong. Okay, it's not strong as the as the covalent and the ionic bonding. So let's go to the summary. Oh, before that, I forgot. Okay, we have the secondary interatomic bonding, what we call the van der Waals. Van der Waals is the arise from atomic or molecular dipoles. Okay, right. Dipoles mean that different charge here. Okay, so between the positive and negative charge here, we have the van der Waals bonding. But van der Waals is very weak. Okay, 3 hydrogen bonding mechanism, let's say inert gas, symmetrical molecules. Okay, despite the hydrogen itself here has the covalent bonding, it also has the van der Waals. So that's why we call the van der Waals is the secondary interatomic bonding. Okay, so it also between the asymmetrical molecules such as hydrogen chloride. Yes, hydrogen chloride is the ionic bonding, but it also has the van der Waals for the secondary atomic bonding. So now HCl has 2 types of bonding. One is the ionic between hydrogen and chloride itself, and also between the molecule of hydrogen and chloride for the secondary, what we call the van der Waals bonding. How the van der Waals form? It is because of the atomic and molecular dipoles. Okay, so molecule is considered the smallest particle of pure chemical substance that still retains its composition and chemical properties. Most common molecules are bound together by strong covalent bonds. Yes, we know the oxygen itself is the covalent bonding, hydrogen, fluorine, and so on. So the smallest molecule is the hydrogen molecule. Why it is the smallest? Yes, because we know the hydrogen only has 1 proton number and 1 electron number. Okay, summary of the bonding. Ionic bonding has very large bond energy, so you have to put a lot of energy to break down the ionic bonding. For the melting point, yes, it's very high. Hardness, it's very hard. But the conductivity is very poor. It can conduct electricity, but in the molten or in the solutions conditions. It cannot conduct electricity in the solid phase, in the solid form. Okay, comment here, non-directional. Sometimes we call it ceramic. Most of the ceramics have the ionic bonding, and so on lah. So between these, the metallic bonding has the lowest melting point, but it also can be high the melting point, such as iron and so on. But for the hardness, it is very soft. For the conductivity, it is very excellent. The metallic bondings are the materials that have the metallic bonding have a very good electrical conductivity. Yes. And the secondary bonding, what we call the van der Waals, it's very low, smallest energy here compared to the other type of primary bonding, and so on lah. Okay, so this is the summary, similar to what I have explained in this table. Okay, so this is the value you can find here that, let's say, the ionic have, for the magnesium oxide we have the 1000 kJ per mole. Is the highest in this table, and the melting temperature, it can be melted at 2800, very high, but still lower than the diamond itself. Okay, so it depends. Not necessarily ionic is the highest melting temperature. It depends on the combination of element itself. Okay, but if you compare the ionic and covalent to the metallic bonding, yes, metallic bonding has lower, comparably lower bonding energy, and the melting temperature is varies, depends on the on the element itself. Okay, so that's it. I think that's it for today. We will continue to the next class for the subject, the crystal structures, APF, and density computations. Okay, so for now, this is chapter 1 for the interatomic bonding. Make sure you do your tutorial, and we will discuss the tutorial. I will give you the answer of the tutorial in the next class, which is next Friday. Okay, where is your tutorial? Here, tutorial 1. Okay, so I'll put it in the Google Classroom. Make sure you do these tutorials. Okay, till the next video, take care yourself. Selamat berpuasa. Esok kita mula berpuasa. Selamat beribadah, but don't forget to do your tutorial 1, tutorial 2 for the chapter 1 here. Okay, thank you. Assalamualaikum dan salam sejahtera.